today's topic is impulse momentum principle. So let us know why we are going to use this method. So this method is used to solve the kinetic problems, which involves force, time and velocity. So if any problem you find with respect to force, time and velocity in the given data, definitely you can go for impulse momentum principle. Before going to derive impulse momentum principle, first of all you must know what is impulse. Impulse is nothing but impact. So what is impact? That is large amount of force, large amount of force acted on a body within short duration. Short duration, that is nothing but impulse. So we need to prove it. That is impulse, I can say it I. So I'm assuming impulse in terms of I. So I is equal to, right, force into time interval, that is t2 minus t1. Our aim is to prove that I is equal to f into t2 minus t1. Similarly, momentum. So momentum, what is momentum? Momentum is nothing but it is a product of mass of the body and change in velocity. So I can say that this is also nothing but in the form of impulse, because its impulse momentum is similar to each other. So I can say that impulse momentum I is equal to impulse momentum. In the terms of impulse we are going to represent momentum also. So I is equal to mass of the body into change in velocity. So we need to prove these two equations are equal. Since I is equal to f into t2 minus t1 and I is equal to m into v2 minus v1, so we need to prove these two are equal and we need to prove the equation is correct or not, right? For that I am going to consider a block of mass m, where this block have initial velocity is v1, final velocity is v2 and time interval is up to t1 to t2, right? So to solve this we need to consider Newton's second law. So according to Newton's second law, F is equal to ma. What is a? A is nothing but acceleration. We know that acceleration, since we know that a is equal to change in velocity by change in time, just substitute it. So m into dv by dt. So send this d to this side. So f into dt is equal to m into dv. If you integrate the both side, you will get the total force into this time interval and mass into in change in velocity. So integrate on both sides. Under the limits 1 to 2, right? So if you integrate both sides, it is nothing but impulse. I is equal to integral 1 to 2 f into dt is equal to, similarly, integral 1 to 2 integral 1 to 2 m into dv. So we are going to do integrate with respect to time. So that is equal to f into t under the limits 1 to 2, m into d with respect to velocity, so that is v integral dv is equal to v under the limits 1 to 2. Finally, I is equal to f into t2 minus t1 is equal to m into v2 minus v1. In this equation, f into t2 minus t1 is nothing but impulse, m into v2 minus v1 is nothing but momentum. So I can say that this equation is nothing but impulse momentum principle.